Something has been wrong with Betelgeuse for 100 years, not the fact that it's dying. Astronomers have known that for generations. Betelgeuse is a red supergiant marking the shoulder of the constellation Orion. It is running out of fuel, and one day it will collapse and detonate as a supernova bright enough to be seen from Earth in daylight. That was never the mystery. The mystery was the rhythm. Betelgeuse pulses. It brightens and fades, and buried inside that flickering there was a second, slower beat, a cycle roughly 6 years long that nobody could account for. Not the Hubble Space Telescope, not the Chandra X-ray Observatory. For decades, it simply sat in the data, unexplained. Last month, astronomers finally saw what was causing it, and what they found is not going to survive what happens next. To understand why this took a century, you have to understand what you are actually looking at when you look at Betelgeuse. Go outside on a winter night and find Orion. The bright orange star at his shoulder is Betelgeuse, and it is about 550 light-years away. The light hitting your eye tonight left that star before the printing press existed. It is a monster, roughly 20 times the mass of our sun, and about 700 times its width. If you deleted the sun and dropped Betelgeuse into the center of our solar system, its surface would swallow Mercury, Venus, Earth, and Mars. Jupiter would be orbiting near its outer edge. Everything you have ever known would be inside that star, and it is unstable. Betelgeuse has burned through its hydrogen and is now fusing heavier and heavier elements in its core, faster and faster, in a sequence that ends only one way. When the core finally builds a heart of iron, gravity wins, and the star falls in on itself in less than a second. So when Betelgeuse started going dark, people noticed. In late 2019, astronomers watching Orion saw something they had never seen before. Betelgeuse was fading, not slightly. Over a matter of weeks, it dropped to roughly 40% of its normal brightness. The shoulder of Orion visibly dimmed in the night sky, to the point where casual stargazers could see the constellation had changed shape. The event got a name almost immediately: the Great Dimming. The speculation was instant. A dying supergiant suddenly losing more than half its light looks exactly like a star doing something final. A generation of astronomers who had spent their careers hoping to witness a nearby supernova started checking Orion every single night, wondering if they were about to see history. They were not. By early 2020, Betelgeuse quietly brightened back to normal. The star had not been collapsing. It had ejected an enormous cloud of dust from its own surface, and that cloud had drifted between Betelgeuse and Earth. We had been looking at the star through a veil of its own making. The end of the world was a dust cloud. But solving the Great Dimming did not solve Betelgeuse. It exposed the real problem underneath. Because when astronomers went back through the brightness records, they found the star was keeping two rhythms at the same time. The first made sense. Betelgeuse swells and shrinks over a cycle of roughly 400 days, the way an enormous unstable star naturally does. Textbook behavior. The second made no sense at all. Layered underneath that pulse was a much longer beat, a slow rise and fall lasting about 2,170 days. Just under 6 years, regular, persistent, visible in observations stretching back generations. Nothing inside a star should do that. The physics of a red supergiant does not produce a 6-year metronome. Something had to be driving it from outside. By 2024, 2 independent teams of astronomers had published the same suspicion. The reason Betelgeuse keeps a 6-year rhythm is that Betelgeuse is not alone. Something is orbiting it. Something is going around the star once every 6 years, and every orbit, it disturbs the light we see. It was an elegant idea. It also seemed impossible to prove. Here is the problem. Imagine standing a mile from a stadium floodlight at night and trying to spot a candle held up beside it. That is roughly the challenge. Betelgeuse is one of the brightest stars in the entire sky, and any companion close enough to orbit in 6 years would be sitting practically inside that glare. They tried anyway. The Hubble Space Telescope looked. It found nothing. NASA's Chandra X-ray Observatory looked. It found nothing. Some of the most capable instruments humanity has ever built pointed at the most famous variable star in the sky and returned empty. A rhythm with no cause and a suspect nobody could photograph. Then a team took a different approach. Instead of trying to outstare the glare, they went after the atmosphere. Look at any bright star on a clear night and you will see it twinkle. That twinkle is Earth's turbulent air bending the light, and through a telescope it smears every image into a soft blur. But if a camera fires thousands of extremely short exposures, freezing that shimmering air a fraction of a second at a time, a computer can rebuild the sharp image hiding underneath. The technique is called speckle imaging. A team led by Steve Howell at NASA's Ames Research Center applied it to Betelgeuse using an instrument on the Gemini North telescope, an 8-meter observatory near the summit of Mauna Kea in Hawaii. Then they did something clever with the timing. They compared two sets of observations, one from 2020, taken when the suspected companion should have been hidden behind Betelgeuse, and one from December 2024, taken days after it should have swung out to its greatest possible distance from the star. The 2020 images showed nothing. The 2024 images showed a point of light sitting right beside Betelgeuse. They ran it down. They checked whether it could be a hot pixel. They checked cosmic rays. They checked whether Earth's atmosphere could have manufactured it. It survived every test. After a century of suspicion, someone had a picture. The team published in 2025, and they gave it a name. Betelgeuse takes its own name from Arabic, where it refers to the hand of the giant. So they proposed calling the companion Siwarha, Arabic for her bracelet, the thing that circles the hand. Informally, astronomers had already been calling it something less poetic, Beetle Buddy. But one detection, using one technique on one telescope, is a claim. It is not a confirmation. Astronomers elsewhere said so directly. The point of light was faint, the method was demanding, and observatories around the world wanted a second, larger instrument to see the same thing before anyone closed a century-old question. That is what happened last month. A team led by Miguel Montargis turned the European Southern Observatory's Very Large Telescope, 4 linked 8-meter telescopes on a mountaintop in Chile's Atacama Desert, onto Betelgeuse. Using an instrument built specifically to suppress the light of bright stars and reveal faint objects beside them, they produced the sharpest image yet of what is almost certainly Betelgeuse. B. Montargis described it as the conclusion of a century-long quest. So Betelgeuse has a companion, a star roughly twice the mass of our sun, young, still settling into the long, stable phase of life our own sun has been in for billions of years. And here is where the story turns. Siwarha orbits Betelgeuse at a distance of about 4 astronomical units. To put that in perspective, that is closer than Jupiter orbits our sun. Now remember how big Betelgeuse is. Remember that its surface would reach out past Mars. That companion is not orbiting at a comfortable distance in clean, empty space. It is plowing through the outer envelope of a supergiant, once every 6 years, dragging through the star's extended atmosphere. That is the rhythm. Every 6 years, a young star plows through the outer atmosphere of a dying red giant. The light leaving Orion's shoulder dips and recovers, and astronomers on Earth wrote that change down in their logbooks for generations before anyone saw the cause. But an orbit like that cannot last. Every pass through that gas costs Siwarha energy. Drag pulls it inward. Its orbit tightens. And astronomers now think that this companion is on a spiral, and that the spiral has an ending, and that the ending arrives before Betelgeuse ever gets to explode. The two stars are expected to merge. Morgan McLeod, one of the researchers studying the pair, put it plainly. The stars may well merge before Betelgeuse goes supernova. That merger would splash gas outward. It would spin Betelgeuse up, and it could change the properties of the supernova itself. Think about what that means. This companion survived the formation of the system. It survived Betelgeuse, swelling into a supergiant. It has been circling that star, unseen, through every year of recorded human history. We finally photographed it, and we photographed it on its way into the fire, and it changes what we are waiting for. Betelgeuse is still going to die. That timeline is measured in thousands of years, not months, so nobody watching this needs to worry about Orion tonight. But the supernova astronomers have imagined for a century may not be the clean collapse of a single lonely giant. It may be the detonation of a star that has just eaten its own companion. Right now, we cannot watch it happen. Siwarha has swung around to the far side of Betelgeuse, buried behind the giant from our vantage point, and it will stay hidden until 2027. The research team has already circled a date and asked the world's observatories to be ready for it. November 26, 2027. That is when Siwarha reaches its greatest separation from Betelgeuse again. That is the next clear look anyone on Earth gets at the doomed star. 100 years to find it, and now a wait to see it again. There is another object out there with a countdown attached to it, one that is far closer to home and far harder to explain, and I'll be covering it next. If you want to see that one when it goes up, subscribe, and I'll see you in the next one.